Hi everyone, so I will be discussing Leetcode daily challenge problem, minimum moves to equal array elements. So in this problem we are given an integer array names of size n, and we want to return the minimum number of moves required to make all array elements equal. And in one move we can either increment an element or decrement an element. So let's discuss it through this example. So in this example, um, we have 1, 2, 3. So in this example, basically, um, what we can do, we can increment this 1 to 2, which requires one more, and decrement 3 to 2, which means this would become 2, this would become 2, this would, and it would require total one increment and one decrement. So this is explanation for this example. In the second example, so in this example, what we can do basically, we can either make all the array elements 9 or all the array elements 2. So if we see, if we want to uh, convert all elements to 9 and convert all elements to 2. So in the first case, when we want to convert all elements to 9, for this one we want to increment by 8, and for this 10 we want to decrement by 1, and for this 2 we want to increment by 7, which is 16, and for this 2 we want to increment 1 by 1, and decrement 10 by 8, and decrement 9 by 2, 9 by 7, so it would be 16. So in both the cases we are getting 16. Now if we try to convert all elements to 1, let's say if we want to convert to 1, we would have for 10 we would require 9 decrements, for 2 we would require 1 decrement, for 9 we would require 8 decrement, which means 18 total moves we would require, which is greater than 16. And a brute force approach to solve this problem is to basically check for all cases. So let's say in this example 2, we basically convert all to 1, convert all to 2, convert all to 9, convert all to 10. Now for this we would require uh, basically three calculations, because we want to calculate three differences, three calculations, similarly three calculations for this, similarly three calculations for this, three calculations for this. Now in total we require 12 calculations, and uh, in general if we have n elements, so here we had 4 elements, if we have n elements we would require n into n minus 1 calculations for this case, which means that it would be order of n square complexity, and so this is not an optimal approach. So the observation here in this problem is that um, we want to if we want minimum moves, we want to sort this array. So this is currently 1, 10, 2, 9. If we sort it, we would have 1 to 9, 10. Now if we sort it, we would basically uh, have um, so now we want to check median. So median in this case is this middle element. So For median, basically what we would do, if the, if we have, let's say, odd elements, so we know the median is this. For even elements, we can check at this index, basically n is 4, so we could check n by 2th index, which is second index, and for this case n is 5, so n by 2 would be again 2, so we would check this index, which is second index here also. So in both the cases we are checking the second index. Now uh, let's say um, we when we choose the second index, uh, we I also have shown the calculation. We would require 16 moves. Now if we try for any case, we would not get a smaller value than this. So I would explain for this example, which is this one. So in this case, for 5, we want to convert all to 5. So if we want to convert all to 5, we would require 4 plus 2 plus 2 and then 5, which means 13 modes we would require. And if we want to convert all to, let's say now we want to check if this median thing is actually true or not. So if we, let's say, try to convert all to 3, we would have 2 plus again 2 plus 4 plus 7, which is 15 modes. So we require 15 modes. Clearly this 13 is less. Okay. So now if we convert all to 7, we would have 6 plus 4 plus 2 plus 3 modes, which is 10. Again 15 modes we require 15 modes from this case. Now if we convert all to 1, we would require 2 plus 4 plus 6 plus 9 modes, which is 21 modes. Similarly, if we try to convert all to 10, we would require 9 plus 7 plus 5 plus 3, which is 16, 24 modes. So clearly the minimum is coming from this median, and this is the explanation to this problem and to the solution of this problem. Time complexity of this in this of this problem solution is of n log n, the, where n is length of nums and space complexity is simply O of 1, because I am not using any auxiliary space. And so also um, basically this was the only thing that I had to cover.